Welcome back to Chem Sleeping Lab, episode 2. It is raining again tonight. Same lab, same rain. Last time we talked about what a chemical is. Tonight we will talk about how chemicals appear as a solid, as a liquid, as a gas. You do not need to remember anything. You can close your eyes. If you fall asleep, that means the lab is working. Let's start with solid. In a solid, the particles are very close to each other. They're held together by a force. We can call it intermolecular force. It is like a quiet agreement to stay close. Because they're so close, they cannot move freely. They can only vibrate a little bit in their own place. That is why a solid has a fixed shape and a fixed volume. This table is a solid. This cup is a solid. Ice is a solid form of water. Even in a solid, there are small spaces between particles, but very small. So solids are usually hard to compress. You cannot easily push them into a smaller size. If you think about salt, sodium chloride, in its solid form, its particles are arranged in a very regular, repeating pattern. We call it a crystal lattice. Many solids have this regular inside, even if outside they look irregular. In safety, solids are more often the easiest to handle, but not always safe. Solid dust can be a hazard. Fine dust of flour or metal or wood can float in air and can burn very quickly. So even a solid, when it becomes very small dust, can act a little like a gas. Now, liquid. In a liquid, the particles are still close to each other, almost as close as in a solid. But the force holding them is a little weaker. They have a little more energy, so they can slide past each other. They can flow. That is why a liquid does not have a fixed shape. It takes the shape of its container. Pour water into a bowl, it becomes bowl-shaped. Pour it into a bottle, it becomes bottle-shaped. But it still has a fairly fixed volume. You cannot easily compress a liquid. Water is the most common liquid we know. But many things we call chemicals in the lab are liquids. Ethanol is a liquid. Acetone is a liquid. Liquids have a surface. At the surface, there is something called surface tension. It is because the particles at the surface are pulled inward. That is why small droplets are around. In safety, liquids are important because they can evaporate. A liquid sitting in an open beaker does not stay there forever. Slowly, some particles at the surface get enough energy to leave and become gas, and that is evaporation. And if the liquid is flammable, that vapor is what actually burns, not the liquid itself. We will talk more about that in a moment. Now, gas. In a gas, the particles are very far apart compared to solid and liquid. The forces between them are very weak. They have a lot of energy. They move very fast in all directions. That is why a gas has no fixed shape and no fixed volume. It will fill any container you put it in. If you release a gas in a room, it will spread to the whole room. Gases can be compressed easily because there is so much empty space between particles. Air is a mixture of gases. Nitrogen and oxygen are gases. Water vapor, the invisible form of water in the air, is a gas. Steam that you can see from a kettle is actually tiny droplets of liquid water in air. The true water vapor is invisible. In safety, gases need special attention for two reasons. First, you cannot see many gases, so exposure can happen without noticing. That is why we use ventilation, a fume hood, an open window, good airflow. They all reduce exposure by removing the gas. Second, gas density matters. Some vapors are heavier than air. For example, gasoline vapor, propane, many solvent vapors. If they leak, they do not go up. They sink and stay near the floor. Ink can flow to a faraway ignition source. Some vapors are lighter than air, like hydrogen and methane. They rise. Knowing this helps you understand where to ventilate. Risk equals hazard times exposure. For gases, exposure control is almost always about airflow. Now, how does a substance change its state? It changes because of energy, usually heat. When a solid gets enough heat, its particles vibrate faster and faster until they can break free from their fixed positions. The solid becomes a liquid. We call that melting. Ice melts to water at 0 degrees Celsius. When a liquid gets enough heat, its particles move even faster until they can completely separate and fly into the air. That is boiling. Water boils at 100 degrees Celsius at standard pressure. Boiling is different from evaporation. Evaporation happens slowly at any temperature, only at the surface. Boiling happens quickly, inside the whole liquid, with bubbles. The reverse also happens. When a gas loses energy, it becomes liquid. That is condensation. That is why water drops form on the cold glasses. When a liquid loses energy, it becomes solid. That is freezing. There are two more interesting changes. Some solids can become gas directly without becoming liquid first. We call that sublimation. Dry ice, which is solid carbon dioxide, does this. It goes directly from solid to gas. And gas can go directly to solid. That is deposition. Frost on a cold morning is an example. In the lab and factory, many safety issues happen during phase changes. Boiling liquid can splash. Rapid evaporation in a closed bottle can build up pressure. A liquefied gas, like liquid nitrogen, expands hundreds of times when it becomes gas, so it should never be sealed in a closed container. Understanding the state helps us predict its behavior. Now, let's review slowly. Solid. Particles are close. Only vibrate. Fixed shape. Liquid. Particles are still close, but can slide. Takes the shape of the container. Gas. Particles are far apart. moves fast, fills the whole space. They can change into each other when they gain or lose energy. When they change their phase, they are still the same chemical. That is all for tonight. Now you can sleep. The rain will continue.